Okay, this method of solving integrals is called using partial fractions. So, very quickly, let's go back to equations that are rational functions. Let's add these two equations together. Well, if you want to do that, you're going to get a common denominator, which is x plus 2 times x minus 2. Alright, if that's the common denominator, that means I'm going to have to multiply this one by x minus 2 on the bottom, which means I'm going to multiply this by x minus 2. Same thing here, I need to multiply this by x plus 2, which means I multiply the top by x plus 2. And then on the top, I would get x minus 2 plus x plus 2, which is 2x over x plus 2 times x minus 2. Now, if I would have started this problem with the integral of 1 over x plus 2 plus 1 over x minus 2, whether or not you remember, you know how to solve this. You can do them separately using u substitution, I guess, but since the derivative of each of those are 1, if u is each of them separately, then du is just 1, nothing changes. So the antiderivative is natural log of x plus 2 plus natural log of x minus 2. Well, what we're going to be doing is we're going to be starting with the integral of this, which we don't know how to solve and is kind of complicated. So this method, what it does is it starts with something like this, and there's a process that helps you get to the fact that that equals that, and then you find the antiderivative. Sounds kind of complicated. It really isn't that bad, just a lot of algebra and a lot of work. So let's look at a problem. I'm actually going to be doing some problems from the book, and I'm going to start with number 2. I don't have the page number right here, so I'll tell you that later. Alright, the question is to solve for the integral of x plus 1 over 6x plus x squared. Alright, so what I want to do is I want to rewrite it in the sum of fractions, kind of like on the last problem. And so the first thing you're going to do is you're going to factor the bottom. We're going to factor out x. Now, to solve for the integral, there's this process called partial fractions that helps us rewrite it in the sum of fractions. So forget about the integral for a little bit. What we're going to do is we're going to say that something over x plus something over 6 plus x is going to equal x plus 1 over x times 6 plus x. I got the x and the 6 plus x from the factors. We're just going to put an a and a b here. If there was another factor, you would put a c. We don't know what numbers those are that add to give me that. So what you do is you try to solve this equation. You're going to multiply, like get a common denominator. So I'm going to multiply this by 6 plus x, this by 6 plus x, this by x, and this by x. And now we have a common denominator all the way across. What that means is that the top of the equation is equal. Alright, and then I'm going to multiply this. 6a plus ax plus bx equals x plus 1. Now what you do is you take anything that has x's and combine them. So this ax and this bx is going to equal this x. And basically you just look at the coefficients. There's an understood 1 right here. So this equation says that a plus b equals 1. You just get rid of the x's and combine the coefficients. And anything that doesn't have an x, you just set that equal. So now I have these two equations. And what you do is you solve one of the equations if you can for a or b and so plug it into the other. So you get A is 1/6. So then you plug in 1/6 for A and solve for B. And so B is 5/6. Now, if I go back and plug in A and B here without the blue, then I have that 1/6 over X plus 5/6 over 6 plus X equals the integral of what I'm looking for. So once I rewrite it, I find the integral of that. It looks complicated, but I know that 1 over 6 is just a number, and this is 1 over x. The antiderivative of 1 over x is ln of x. So it's 1 over 6 ln of x plus, this is just a number, this is 1 over 6 plus x, no derivative on the bottom, just 1. So it's 5/6 ln of 6 plus x, and then plus c. Remember I told you today in class that there was a lot of algebra? Well, there is, and there's a lot of process, but once you get started with it and try it, I think that it won't be too bad. Let's try another one. Okay, this one is going to be number 25. So we have the integral of 3x plus 6 over x squared plus 3x. So first thing you do is you factor the bottom. That's x times x plus 3. And then you say, oh, well, something over x plus something over x plus 3 equals this equation. And that's where you just put your a and your b. So then you get a common denominator. This has got to have x plus 3. This has got to have x plus 3. This has to have an x, this has to have an x. All the tops are now equal, so 3x plus 6 equals ax. Now I'm going to go ahead and multiply it, a times x, a times 3. Now, anything with x, I combine. I take off the x's and combine the coefficients, so 3 equals a plus b. Anything with not an x just combines. Here that you can get the a is 2. Substitute in your 2 and you get b is 1. So now you go back and you rewrite the equation. And you have, let's see, 2 over x plus 1 over x plus 3 equals that equation, so we just find the antiderivative of that. And the antiderivative would be 2 ln of x plus ln of x plus 3. Alright, this is number 3. The integral of 8 over y cubed minus 4y. Alright, that factors. You can factor out a y, then you're left with y squared minus 4, so then you can factor that. So this time you have something over y. I'll make it a little bit smaller here. Something over y plus something over y minus 2 plus something over y plus 2, because y minus 2 times y plus 2 gives you the y squared minus 4. So this time we have an a, we have a b, and we have a c. I think this is probably the biggest kind of problem. I don't think you would have d's and e's. Alright, so on the a one, you've got to multiply that times y minus 2 and y plus 2, which is y squared minus 4. On the b one, you have to multiply by y and y plus 2. If I multiply that, that's y squared plus 2y. On the c one, you have to multiply by y and y minus 2. and that's y squared minus 2y. Now all the tops are equal, so 8 equals ay squared minus 4a plus by squared plus 2by plus cy squared minus 2cy. And I just multiplied out all the top. Okay, anything with y squared comes together. There's no y squared over here, so it's like 0y squared. So a plus b plus c equals 0. Then you combine the things with y's. 2by minus 2cy. Drop the y's. There's no y on the other side, so that equals 0. And then you combine the negative 4a equals to 8. Alright, that gives you a is negative 2. Now I can't plug in a into the second equation, but I can plug it into the first equation here. Negative 2 plus b plus c equals 0. That would give me b plus c equals positive 2. And now to solve it, I have this equation and this equation that you can do elimination on. I'll do that separately. 2b minus 2c equals 0. And b plus c equals 2. You can actually solve for b or c if you want to and plug it into the 2b minus 2c equals 0. Or here, if you'd rather, you could solve for b or c. That might actually be easier. Or you could do elimination if you remember it. So I'll just solve here, I guess, for b or c. You get 2b equals 2c, which means b equals c. You can come over here, plug in your b. Or you could have plugged in c, either one. So if b is 1, that means that c has to be 1. And earlier we got that a was negative 2. So a, b, and c. So then we go back and rewrite our equation. We have negative 2 over y plus 1 over y minus 2 plus 1 over y plus 2. We take the integral of that, and you get negative 2 natural log of y plus natural log of y minus 2 plus natural log of y plus 2 plus c. Alright, this problem is number 1. And I want you to try this one. And then this problem is number 4. And I want you to try this one. Now on number 4, I will tell you that you can go ahead and get rid of the s plus 1s. And if you do that, you end up with 2 over s times s plus 2. And then now you just solve it the way that you have been. You don't have to worry about that extra s plus 1. Alright, try those two, and you'll be done for today.